We're about to dig into a topic that's, frankly, terrifying. But we're going to use the latest scientific models to truly understand what the real aftermath of a nuclear war would look like.
So, let me just start by asking you a question. When you picture a nuclear bomb, what do you think is its deadliest effect? The blast? The radiation?
Well, according to decades of scientific research, it's not what you think. The deadliest part is a brutal, planet-wide climate shift that comes after. It's the darkness.
To really understand that darkness, we have to start at the very beginning. We have to look at the fire, the initial spark. As of 2024, that's the world's total estimated nuclear arsenal. Over 12,000 weapons, held by just a handful of nations, many of them on high alert, ready to go.
And the leap in power from the past is it's hard to wrap your head around. The bomb that destroyed Hiroshima was 15 kilotons. Today, a single modern submarine can carry warheads with over 7 times the explosive power of all the bombs used in the entirety of World War II.
You see, in a modern conflict, the targets aren't just military bases. There are cities, are industrial centers, places absolutely packed with fuel. A nuclear detonation over a city would create a firestorm, a massive, self-sustaining inferno with temperatures briefly hotter than the surface of the sun.
And this is where the real chain reaction kicks off. These unimaginable fires are the engine of a global catastrophe. They create a world of soot.
This brings us to a concept that was first theorized back in the 1980s, nuclear winter. And I want to be clear, this isn't science fiction. It's a scientifically modeled consequence of what happens when you inject massive amounts of soot into the upper atmosphere.
So you're probably asking, how does soot from the ground get high enough to block the sun for the entire planet? Well, it's a 4-step process. First, ignition from those city-sized firestorms. Second, the incredible heat creates its own weather system, a giant storm cloud that acts like an elevator. Third, this elevator punches the black soot straight up into the stratosphere. And fourth, and this is key, because the stratosphere is above the clouds and rain, the soot doesn't get washed out, it just stays there for years.
So what does a world shrouded in soot actually look like? Well, the consequences are staggering. This is the nuclear winter. The scale of the cooling is just mind-boggling. During the peak of the last ice age, the planet was about 6 degrees Celsius colder on average. But climate models predict a major nuclear war would cause an average temperature drop of 11 degrees Celsius. We're talking about plunging the world into a cold that's deeper and comes on much, much faster than the last ice age.
And this isn't some brief cold snap. Nope, the cooling would peak in the first year, but that severe agriculture-killing cold would persist for at least 5 years. It would take a full decade for the soot to even begin to clear, with a full recovery taking way, way longer.
A dark, frozen planet leads to one single inevitable outcome for any survivors on the ground.
A landmark study in 2022, published in the journal Nature Food, calculated the human cost. Following a major nuclear exchange, they estimated over 5 billion people could starve to death, not from the bombs, but from the darkness that comes after.
And here's the most important part. This isn't a localized problem. The study is clear. Mass food shortages would affect almost every single country on Earth, whether they were involved in the war or not, because the soot in the atmosphere spreads globally. No one is safe.
I mean, the equation is brutally simple. No sunlight plus year-round freezing temperatures, that means growing seasons are completely eliminated. Global crop production collapses, the intricate system of trade and supply that feeds humanity just stops working.
But this chain reaction has one last unbelievably cruel twist. For anyone who somehow survives the cold and the famine, a new threat emerges from the sky.
Imagine it for a second. After 10 long years of darkness and freezing cold, the soot finally begins to settle. The sky brightens, the sun returns. You'd think the nightmare is finally over.
But it's not. See, while that soot was absorbing sunlight high in the atmosphere, it superheated the stratosphere. This process triggered chemical reactions that absolutely destroyed Earth's protective ozone layer. Models show a peak global loss of 75%.
Without the ozone layer, the returning sunlight is now intensely toxic. Extreme levels of UV radiation would pour down, scorching any plant life trying to regrow and posing a grave threat to any human or animal survivors. First came the fire, then the ice, and finally a new kind of fire from an unfiltered sun.
So we come full circle. The ultimate danger of nuclear war isn't a single event, but a cascade of system failures. an attack on the atmosphere, the climate, and the global food supply all at once. It really forces us to ask a difficult question. How resilient is a system that can be so completely broken by its own creations?